So here's the practice quiz, and the quiz that you're going to take is going to look almost exactly like this, except the element in the top right corner is going to be a different element. So on this practice quiz, we're going to answer all of this first page, all about aluminum, and we're going to do this without using our periodic table. Everything we need is given in this box. Okay, so the atomic number is always the smaller number. So the atomic number is 13. And that is the same as the protons and the electrons. Remember, the electrons we just say for now because that eventually can change, but it's always the same as the protons. The symbol is Al, and the element name is aluminum. Those are just given in the box. The mass number is the bigger of the two numbers in the box. So that's going to be 27. That's the mass number. And that is how they get that number for an atom. It's the protons plus the neutrons. So the mass number is the protons plus the neutrons. Speaking of protons, the protons, we just said earlier that the protons are the same as the atomic number. So that means that the protons are 13. And then so are the electrons, because that's what we said earlier, that the protons and the electrons are the same as the atomic number. Where are the protons located? The protons are located in the nucleus. Along with the neutrons. So the protons and the neutrons are both located in the nucleus. Okay. Neutrons, we need to do some math to get the neutrons. We're going to take this number minus this number to get the neutrons. So we're going to do 27 minus 13. So we're going to have 14 neutrons. And so how did we find that? We did the mass minus the protons, or you could say mass minus the atomic number. Both of those answers would be acceptable. So the neutrons are 14 because 27 minus 13 is 14. The electrons, we said those were 13. Where are they located in an atom? They're in the electron cloud. You could also say that they are in the energy levels, or you could also say they are outside the nucleus. All of those answers would be acceptable. The Bohr model. So let's do the box on the right first. So how many electrons can fit in the first energy level? Well, we're not concerned about aluminum right now. We're looking at how many can fit total. So in the first energy level, we can have 2 electrons. In the second energy level, we can have up to 8 electrons. And in the third energy level, we can also have up to 8 electrons. Okay? So our Bohr model, we're going to need to draw some circles. Okay. In the nucleus, you can put that there are 13 protons and 14 neutrons. And then we're going to go ahead and draw our rings, our energy levels. Oops. Whoa, that's an interesting shape. There we go. And let's do one more. All right. Okay. So here's a hint for you. It says over here on the right, next to Bohr model, it says how many electrons can fit. So if you don't remember, how many dots to draw or what you're supposed to be doing here, look over there. It says how many electrons. So we're taking our electrons, and those are what we're drawing around the Bohr model. So we need 13 dots. So we said 2 can fit in the first ring, so we're going to have 2 there. You always start with the ring that's closest to the nucleus and work your way out. So you fill up that ring first with 2, it's full, so then you move on to the second ring. And that ring can hold up to 8 electrons, so we're going to go ahead and put 8 dots for 8 electrons. Okay, and if we count up how many we've drawn so far, we'd have 2 in the first ring, 8 in the second ring, so 2 plus 8 is 10. So we've drawn 10 electrons, but we need 13. So that means we need 3 more electrons. So go ahead and put 3 more electrons there. So that is the Bohr model. The electron configuration, now this is going to be how many dots we have on our, how many electrons we have on our atom, for our atom, not how many can fit. So this is going to be, and there's a hint over here on the right, it says look at the Bohr model. So this is going to be for our atom of aluminum. And you start with the closest to the nucleus, so there's 2 electrons here. So that's why I have a 2 there. And then we work our way out to the next ring, and there's 8 in that ring. And then in the last ring, there are only 3. So 2, 8, and 3. That's the electron configuration for aluminum. The period, these next few, we can get, these next 4, period, group, valence electrons, and energy levels, we can get these all from the Bohr model. So the period, we're going to look at the number of rings we used, the number of energy levels. We used 3 energy levels. So that actually goes over here, energy levels. So the period is the same value as the energy levels. So why don't we go ahead down to energy levels and fill that in. So we said there's 3, and so that corresponds to the period. The energy levels correspond to the period. The period corresponds to the energy levels. Let's move up to the valence electrons. Remember the electrons, the valence electrons are the electrons in the outermost energy level. So where do you look to get this number? You look in the outer energy level. And there are 3 electrons there. So there's 1, 2, 3 electrons in the outer energy level. You could also look at the last number of the electron configuration. That's also correct. So you can either look here or here to get this answer, the valence electrons. Okay, both of those would be correct. And finally, the group. Now we have to be careful with the group because sometimes it's you have to put a 1 in the front. So we look at the valence electrons to find the group number. There are 3 valence electrons, but it's not in group 3. It's in group 13. So remember, we skipped the transition metals in the middle of the periodic table. So if it has 1 valence electron, it's in group 1. If it has 2 valence electrons, it's in group 2. But if we have 3 valence electrons, we're in group 13. 4 valence electrons is group 14. 5 valence electrons is group 15. So on and so forth, all the way over to group 18. Okay? The shorthand, that's where we have the element symbol. So we have aluminum, so our symbol is Al. And if we scroll back to the top, we're going to take the mass number and put that over top of the atomic number. It's always going to be the big number over the small number. So 27 over 13. And that's going to be on the left side of the symbol. 27 over 13. Now remember, you're not using your periodic table for this page. So this question here is actually going to be worth a bonus point if you can get it right. So aluminum, it's not a metalloid, it's not a noble gas, it's not a halogen. Aluminum is just a metal. It doesn't really have any other specific special designation. It's just a metal. Okay? So when you take the quiz, this page will be on paper, and you will not get to use your periodic table for this page. But if we scroll down to the next page, the multiple choice section, you can see it says now you get to use your periodic table. and this part will actually be on Canvas, this multiple choice section. Answer the following questions based on information you discovered while completing the periodic table project. So elements are arranged on the periodic table by, this is going to be the main way that they're organized, and that's by increasing atomic number. They start at 1, hydrogen, and go up from there. 2 is helium, 3 is lithium, 4 is beryllium, so on and so forth. They go by order of atomic number. The part of an atom, the subatomic particle that's found in the nucleus that has no charge or is neutral, that is the neutron. The neutrons are neutral and in the nucleus. Which subatomic particle, determines the atomic number? The atomic number is determined by the protons. The protons determine the atomic number, which determines the element. Okay, not the electrons. The electrons are just for now. We're talking about always. What's always determining the atomic number, and that is the protons. Where are the electrons found? We actually already answered this question up above, but the electrons are found in the energy levels. The electrons in the outermost energy level of an atom that are responsible for an element's chemical properties are the valence electrons. Valence electrons. What do the group 2 elements have in common? Group 2. So if you look above, let's go back up here to this page. We said that the group is the valence electrons, corresponds to the valence electrons. Okay, so let's keep that in mind. Group and valence electrons go together. Period and energy levels go together. So we want to know about the group 2 elements. What do they have in common? Well, group and valence electrons go together. So group 2, they're going to have 2 valence electrons. Now that's correct. But wait, let's read all of our options. It cannot be A because period goes with energy level, not group. But alkaline earth metals, when we colored in our periodic table, group 2, we colored that in orange. Group 2, they are alkaline earth metals. So B is also correct. So our answer should actually be D, both C and B. Group 2, they have 2 valence electrons and they are called the alkaline earth metals. So D is the most correct answer. Which energy level will you find valence electrons for nitrogen? So we're looking at what energy level will we find the valence electrons for nitrogen, which has an atomic number of 7. You may find it helpful to draw a Bohr model. Okay, you can draw a Bohr model, or we can just do the electron configuration and figure it out as well. So let's do that. So it has an atomic number of 7, so that means that it's also going to have 7 electrons. How many electrons go in the first energy level? 2. So for our configuration, we're going to start with 2. How many electrons can go in the next energy level? Well, we can fit up to 8, but we've only got 5 left, because if we have 7 total and we've already used 2 of them, then we're going to have 5 electrons left. So in the first ring, we're going to have 2 electrons, and in the second ring, we're going to have 5 electrons. And then we've run out of electrons. So the valence electrons are the electrons in the outermost energy level. There's 5 electrons there, and they are in the second energy level. So 7 is B. We will find the valence electrons for nitrogen in the second energy level. Considering electrons have very little mass, where is the majority of the mass of an atom located? So they're saying that electrons have very little mass, so it's not where the electrons are. So the majority of the mass is where the protons and the neutrons are. Okay, so the protons and the neutrons are in the nucleus. So the nucleus has most of the mass of an atom. Considering the charge of all the subatomic particles, what is the overall charge of the nucleus of an atom? So we're only looking at the nucleus. So like on the last question, we said the protons and the neutrons are in the nucleus. Well, the charges, because we're looking at, we want to figure out the charge. The charge of a proton is positive, and the charge of a neutron is neutral or 0. Now, the only particle in the nucleus that has a charge are the protons, and they're positive. So that means that the nucleus must also be positive. What makes group 18 on the periodic table different from all the other groups? Group 18, these are the noble gases. We colored them brown on our periodic table. They're the very last group to the right. Why are they so special? Now let's read our options. A, they have no valence electrons. B, they react with all elements. C, they have full outer energy levels. Or D, all of the above. Well, first of all, it cannot be D because A and C contradict each other. A is saying they have no valence electrons, and C is saying they have full valence electrons. So it can't be D. It cannot be all of the above. And there has to be at least one valence electron because these are the electrons in the outer energy level. So you can't have an element that has no valence electrons. So C is our answer. They have full outer energy levels. Their electrons are full valence electrons. And that means that they don't react with other elements. So they actually don't do that. So it's not A, it's not B either. So it is C. Considering the charge of all the subatomic particles, what is the overall charge of an atom of oxygen? And then I gave you the example of phosphorus. So let's just pretend I said phosphorus here. So phosphorus has 15 protons, 16 neutrons, and 15 electrons. And we're looking at overall, not just the nucleus like we did before. So we are going to consider all three particles. So remember, protons are positive, neutrons are neutral, and electrons are negative. So because we're looking at the charge of something, we can ignore the neutrons since they don't have a charge. So we have 15 positive protons and 15 negative electrons. So if you combine 15 positives and 15 negatives, then they will cancel each other out. And if they cancel out, that means the overall charge is going to be neutral or 0. 15 minus 15 is 0. Atoms of elements that are in the same group have the same number of blank, and elements in the same period have the same number of blank. Well, let's go back up to the first page like we did before. And it says the period is the energy levels. So however many energy levels it has tells us the period. So if elements are in the same period, then they have the same number of energy levels. In groups, we said go with the valence electrons. So if elements are in the same group, they're going to have the same number of valence electrons. So let's go back down to 12. So elements in the same group have the same number of valence electrons. Elements in the same period have the same number of energy levels. So that's going to be B. Okay? True or false? Hydrogen is located in the top of group 1 because it is a metal with one valence electron. So yes, it is in group 1. That's true. It does have one valence electron, but it is not a metal. So that is false. Hydrogen is a nonmetal. It is the only nonmetal that's on the left side of the periodic table. And if you notice when you colored it in on your periodic table, you colored it in blue, but the rest of group 1 you colored in green. Lithium, sodium, potassium, rubidium, cesium, francium. Those are all green on your periodic table, and you colored hydrogen blue. So hydrogen, it is in group 1 because it has 1 valence electron, but it's a little different because it's not a metal. So 13 is false. 14, true or false. Helium is a noble gas because it has 8 valence electrons. It is true that helium is a noble gas, but helium doesn't have 8 valence electrons. It only has 2 valence electrons. So that is false. Remember, we talked about why helium is with group 18 instead of group 2. And it's with group 18 because its energy level is full. Remember, that first energy level can only have 2 electrons. And so helium, because it has 2 electrons, its energy level is full. And that's why it goes with the noble gases. And then 15, label. So I'm just going to highlight here to make this a little bit easier. So the halogens are group 17. The noble gases, we colored those in brown, so I'm going to use brown. That's group 18. The alkali metals, we colored those green on ours, so I'll use green. That's going to be, careful, it's going to be that one down. Don't include hydrogen, don't color hydrogen in with those. The alkaline earth metals, those are orange on our periodic table. That's group 2. And the metalloids, those are purple, so I'll use purple as well. That's boron and silicon. Okay. And being able to use your periodic table for that, number 15 should be definitely pretty easy now. You should have all of those labeled and colored on your periodic table.